Alright, we're going to do simple probability. That's your title. Simple probability. Simple means what?
Easy.
Easy. Not complicated yet.
Yes.
Not today.
Not today. Very
So 1, 18, 17. Sample probability. Alright, we good? Alright, your simple question is how do I find the probability? Blushing? What's like, oh, my sweater's wet. I think, how's my paper wet? Of an independent event. Make sure the date's on there. Make sure there's some questions on there. Remember, notebook checks are worth how much? It's in the 20% category, but how many points is each notebook check?
Darlings.
It's 100.
Oh. So they can save you?
It says out of 10, but when I put it in the grade book, I weighed out of a test grade, or like a test grade out of 100. That's why, for some of you, your homework grade was a little bit higher, even though you didn't do much homework, if you did your notes. Okay? So if I have 3 notebook checks, let's just pretend there's 3 notebook checks, that's 300 points. Yes? How much is each homework assignment? 4. Literally just 4. So how many homework assignments do you need to equal 3 notebook checks?
75.
75. Do you think you're going to have 75 homework assignments?
No.
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 So is the notebook important?
Yeah.
Yes.
Yes. Okay? Yes, homework is so important to help that grade, but your notebook is really important. Some of you just skip out on the notebook and just don't do it. That's fine and dandy. You're also missing 300 points. Okay? You good? Alright. Let's talk about independent events. What does it mean to be independent?
Solo.
By yourself. Alone. Are you dependent or independent right now?
Dependent.
You're dependent. Who are you dependent on?
Parents.
Your parents or your grandparents, whoever you live with, right? You're dependent on their insurance or them, yeah, the house over your head, wherever you're living. You're dependent on them to pay the gas bill, the water bill, all those things, yes? Buy you food, hopefully. Okay? You are dependent on all of them. When do you become independent?
18.
No.
Oh, so well, legally.
When you get your own job, when you're not living at home, when you're paying your own bills, when you're not asking for money, yes? At that point, you are then independent. 18 is a magical pretend age.
Pretend age.
They can choose to kick you out.
They can, but
My mom too.
I'm like, chill out, man.
My mom keeps telling me, you don't have a job by 18, you're getting out of my house. I'm like,
you should have a job as soon as you graduate.
I want to have a job already.
hard.
Alright, so independent, it says, if the occurrence of one has no effect on the occurrence of another. What's an independent something besides being on there? What's something else that doesn't have to rely on anything else? What do you think of? The same.
Is it really anything?
Yeah. Numbers? Like what?
Square. Doesn't really anything.
Sure. And so what's independent? Anything else in your mouth? What's something that's independent and doesn't rely on anything? Think of something easy. Maybe water. Most living things depend on something
A
else.
lot of things depend on a lot of
Everything
things.
means something.
Like
everything depends on everything.
Concrete?
You need material
What?
concrete.
Where did that come from?
Concrete depends on what?
Foundation. You need a foundation.
That's a lot. Unless it's just there already, right? Like we just walk somewhere and there's already concrete, well, it doesn't depend on anything. A table? Okay.
What a waste. Look at my foundation.
Alright, we're gonna do candy.
Oh, wow.
And we're gonna have a bucket of candy. Now does the bucket of candy depend on anything? Not really. We just have a bucket of candy and we're gonna pick out candy. We're not getting candy. Alright, so in my bucket of candy, I have 3 flavors. Or 3 types, I should say. I have Skittles. Now each time I write something, that means that's how many items this is. Do you understand? So like there's little snack bags or whatever, so if I write Skittles, that's 1 bag of Skittles. If I write Skittles again, that means it's another bag of Skittles. Understood? Okay. So I have Skittles, there's some Snickers, any chocolate. There's Starburst. There's another bag of Skittles. There's another bag of Skittles. I don't know. There's a Snickers. Maybe it's left over and it's putting my life. There's another bag of Skittles. There's some Snickers. There's some more Skittles. There's some more Snickers. More Skittles. Starburst. Skittles. And so here's my birthday candy. Let's pretend it came from my house because I can't really eat Skittles. So there you go. What?
You told me to come through later. Let's see.
No. Alright, first problem. Ready? How many total pieces
Roll up to the top.
of candy are in the bucket? How many total pieces of candy are in the bucket? almost cookie season. Alright, how many are there total? 14. Good. Okay, we need that number. Why? If the total is going to be your what? Denominator. Very good. Alright, so it's going to ask, what is the total probability? Of selecting a Skittles, now we need a bag, right? From the bucket. Remember, you need correct probability notation. You need a fraction. You need to reduce it if possible. I'm not caring about the decimal, but I do want a percent. Okay? So those are the things you gotta do. You need proper notation, fraction, reduce if possible, and then percent. So what's it asking for?
Pulling the Skittles out of the bucket.
Pulling Skittles out of the bucket, okay? So now we have Skittles, Starburst, and Snickers, which all start with S, so it's kind of hard. So let's say probability of SK, right? That way we know it's actually Skittles. How many Skittles are in the bucket?
8.
Is there 8? Okay. 8 out of how many? 14. Very good. Which then does what? Simplifies to what? 4 over 7. Which now you're going to give me a what? A percent. Very good.
Are we doing decimal first?
I don't really do the decimal. You can do the decimal. Yes, you have to find the decimal to then do it. Do what?
57.14 or 50?
I don't know. 57.1? Good. Good? Makes sense? Okay, here's the next one. Oops, letter C, not C. Letter C, what is the probability? Of selecting a Snickers. Alright, so we're going to do probability of Snickers, which is what? 4 over 14, which reduces to what? 2 over 7, which is what as a percent? 26?
Yeah.
Okay. Good? Alright. Lastly, what do you think I want you to find? Probability of Starburst. Very good. probability of getting starburst? 2 out of what? Which is 1 over, which is? Good? Okay. Let's do some more. We're going to switch it up. We're not going to do candy anymore. We're going to leave the candy alone. We're going to go to a die. Singular for dice. We'll go over cards starting today.
That's exactly what I said when I got on the phone.
Alright, example 2 is going to be a die. How do you spell the singular die? A color die. Singular. So you can do singular dice. Big die. Because you can say dice too, but normally dice is. Okay. How many sides on a die? There's 6.
Oh, I'm still giving numbers.
There's 6 sides. You have 1, 2, 3, 4, 5, and 6. Yeah? So there's 1, 2, 3, 4, 5, and 6. Alright, so my question is, what is the probability of rolling a 4? What is the probability of rolling a 4? Yes. Does 4 rely on anything or is it independent? It's independent. 4 does not rely on anything else, it relies on me rolling the die. Right? So what's the probability of a 4? 1 over 6. Why is it 1 over 6?
Only one side of 4.
There's only one side that's a 4 out of my 6 sides, right? So 1 out of 6, which is what is a decimal? 16.7? Because it's 6, 6, or
Yes, a lot of sixes.
it ends in a 7 because it rounded for you. Alright, next question. What is the probability of not rolling a 1? What is the probability of not rolling a 1?
The line over ones, no, right?
So yes, line over the no. Think about what you do first. Alright, so the probability of a 1, but we're not asking for a 1, so we put the line over it. So what is the probability of not rolling a 1? 5 over 6. How'd you get 5 over 6?
Because there's 5 things you can get.
Because there's 5 other things you can get besides the 1. In other words, I don't want the 1. Which is what? 83.3? Okay. Good? Okay. Example 3. Deck your cards. If you have a deck of cards, you can get them out. especially if you don't know your deck of cards. I'm going to refer you also to the Algebra 2 book, page 690. It shows the deck of cards, but that's not really going to help you in class. Just so you know, it'll only really help you at home. So you have a deck of cards on page 690. It'll show all the deck of cards. And you have a deck of cards that actually is easier. Okay? Questions? Alright. What we're going to do right now is this. I'm going to take out a deck of cards and we're going to talk about it real quick. Alright, remember you have 4 suits in the deck of cards. A suit is a category. You have your spades, you have your clubs, you have your diamonds, and you have your hearts. Yep? Okay. So, my first question to you is going to say, what is the probability of picking a heart? Now, how many of you have actually played cards? So you guys are going to have a little bit easier time. So what we're going to do right now is if you have no idea what a deck of cards consists of, I'm going to go through them with you really quick. So there's, you can count them for me, there's 1, 2. How many? 13. So, the probability of a heart is what? 13 out of 52. Very good. Now, before we keep going, really quick, if there's 13 hearts, how many diamonds are there going to be then? 13. How many spades? 13. How many clubs? 13. So everything has 13. Okay? Okay. So now, we have 13 out of 52, which does reduce to what? It does give you 1 4. Which is what is it? Percent? 25. Good? Make sense? Alright, next one. What's the probability of a 4? A whole deck of cards. Think about what's the probability of getting a 4. Never play cards, this is easy. Never play cards. This is why you need to deck of cards. How many 4s are there in my whole deck? 4. Out of how many cards? 2. Which reduces to what? 1 over 13.
Yeah, actually.
What is it? 7.7%. We good?
Yep.
Any questions? Basic probability should be relatively easy, right? We could do another one based on marbles. Like you read the problems before. You have a bag of marbles. There's 6 yellow, 4 green, 5 blue, and 2 red. Right? What's the probability of picking a red? That kind of thing. Same thing. Yeah. We just make it hard. Because that's like you've never seen most of this stuff. The only thing you've never seen before is quadratic.
And look, that's what you said.
So I just add on to it. Just like rounding, you guys learned that early on too. Alright, we good? Other questions? We have a summary, so.